Next, we're going to look at integrals where the power of cosine is positive and odd. And the only difference here is that instead of saving a sine for du, we're going to save a cosine for du. Notice that the power of sine of x is actually negative. It would be negative 1/2 here because the radical is under the denominator. But that doesn't matter because our cosine is positive, and that's all that we care about. So we're going to save a cosine of x for du. So just writing this in all powers, I'm going to write this as cosine cubed of x and sine to the negative 1/2 of x dx, bringing that above the denominator and unwrapping the radical. And then I'm going to split the cosine up. I'll have cosine squared of x times sine to the negative 1/2 of x. And then in parentheses, we're going to have the extra cosine of x, which we are going to hold on to. Now, remember, we know that sine squared of x plus cosine squared of x is equal to 1. So that means cosine squared of x is equal to 1 minus sine squared of x. So where I have a cosine squared of x, I'm going to replace it with 1 minus sine squared of x. So this will be the integral of 1 minus sine squared of x times sine to the negative 1/2 of x times that reserved cosine of x, all with respect to x. And now I'm going to follow the process through. I'm going to distribute. So we'll distribute the 1, which gives me the integral of sine to the negative 1/2 of x times cosine of x dx. We'll distribute the negative, so we'll have the integral of negative. Now this is a little bit tricky because you have sine squared and sine to the negative 1/2 power. So 2 plus negative 1/2 gives me sine to the 3/2 power of x. And then we've still got our cosine of x dx. Believe it or not, this direction is actually a little bit more simple because if we let u be sine of x, then u prime is just cosine of x. We don't need a negative here. So du is just cosine of x dx. And we have everything that we need. So this one is going to be the integral of u to the negative 1/2 du minus the integral of u to the 3/2 power du. And we'll evaluate that. So we'll have u to the negative 1/2 plus 1 over negative 1/2 plus 1 minus u to the 3/2 plus 1 over 3/2 plus 1, all plus c, which gives us, let's see, we'll have u to the 1/2 over 1/2 minus u to the 5/2 over 5/2, all plus c. And then coming up here, that gives me 2 times u to the 1/2. I'm not going to change that to the square root of u since we're going to be plugging a sine into it. Minus 2/5 u to the 5/2, all plus c. And then we just plug our sine of x back in. So we'll have sine to the 1/2 power of x with a 2, and then minus 2/5 sine to the 5/2 power of x, all plus c. And that's your final answer. So you can see this problem from start to finish. Here's another one with an odd positive cosine. So I'm going to start by reserving a cosine. So we'll have cosine to the 4th of x, sine squared of x, and we'll have that other cosine of x out to the side. Notice that I've got a cosine to the 4th power of x. So we're going to write that cosine to the 4th power of x, just like we did with the sine, as cosine squared of x squared. And then I'm going to replace the cosine squared of x with 1 minus sine squared of x. And then I'm going to FOIL all of that out and get 1 minus 2 sine squared of x plus sine to the 4th of x. So that's what I'm going to replace here instead of cosine to the 4th of x. So I'll have the integral of 1 minus 2 sine squared of x plus sine to the 4th of x, all times sine squared of x, all times cosine of x, all times dx. And when I distribute, I have the integral of sine squared of x, cosine of x, dx. That's the first one. Minus 2 times the integral of sine squared times squared gives me sine to the fourth of x, cosine of x dx. And then distributing the last one, I get plus the integral of sine to the sixth of x, cosine of x dx, because I'm adding the 4 and the 2. So I'm going to let u be sine of x, which means u prime is cosine of x, and du is cosine of x dx. So this gives me the integral of u squared du minus 2 times the integral of u to the fourth du plus the integral of u to the sixth du. And this will give me u cubed over 3 minus 2 u to the fifth over 5 plus u to the seventh over 7, all plus c. And when I plug my sign back in, I get 1/3 sine cubed of x minus 2/5 sine to the fifth of x plus 1/7 sine to the seventh of x, all plus c. And that will be my final answer.